Welcome everyone. Today we have our another new episode. This episode very important. We will discuss about cloud computing, and we have our world famous speakers, Professor Rob and Professor David. Professor Rob, how you want to analyze today's topic?
Good morning. Why am I ever looking forward to the time change? Cloud computing. So the cloud computing effort is kind of interesting in that it's in a way it's a return to the past. We started off in the computing environment with mainframes and the concept of everything being centralized and protected behind a priesthood of MIS, Management Information Systems, who managed those systems for us and who we always had to work through to get things done, which often meant that if you needed a particular application or a particular project accomplished, you had to put together a proposal. The proposal was supplied to what we now call IT. IT would work on that proposal, and months, sometimes years later, they would give you back something that somewhat resembled what you asked for. It was not an ideal situation, but the advantages were it was relatively secure. Users didn't have to manage the equipment, though they did often have to understand the programming, and the mainframe was operated much like it was an appliance. Then we pivoted to personal computers and client server computing, which put a lot more of the burden of the computer on the individual. We managed to a certain extent our own PCs. A lot of them are centrally managed, but for the most part, the processing power is distributed, and with it comes a certain amount of responsibility and complexity, because instead of having one operating system or maybe two mainframes for a large company, you now had thousands, one for each employee, which created complexity. On the other hand, users had ultimate control. We could load Excel or a database program or whatever. It's when I came into technology, I had a little database program and I had Excel. Actually, I had Lotus 123 back then, and WordPerfect. And then you could do your own stuff. The failure of the mainframe, that early mainframe environment, was it just wasn't very responsive to the customer, but it had advantages. Well, the market ever since then has wanted to go back to some of the good things with regard to centralized computing, but not really the bad things. They still want to be able to do, users still want to be able to do and get done what they need done. They don't want the IT priesthood anymore. And the cloud showed up, and the cloud kind of promises a mainframe-like centralized experience where somebody else is kind of managing security, somebody else is handling the ecosystem, somebody else is making sure the stuff is up and running. But you're still able to work as if you had your own personal computer. You can implement your projects. You can execute on the things that you want to get done, but you don't have to maintain the overhead. You don't have to maintain the costs. And so it kind of looked like initially the best of both worlds, but now you had to move your on-premise work to the cloud, and you lose a certain amount of control, as we saw with outages that each of the major cloud providers has had over the last few years. That lack of control does mean that when there is an outage, it's a surprise. So I have to point out, when a mainframe went down, you didn't get a heck of a lot of notice in those situations either. Sometimes you might get 60 seconds as the thing came down. Other times you might just drop offline. So then we had hybrid, and the idea was for those things that were really critical and you needed to have control over, you maintain them on premise. And for everything else, you put it up on the cloud, and that gave you kind of the best of both worlds, and sort of not. And we discovered that when the pandemic hit, because now people had to come in and maintain the on-premise stuff, but they didn't have to come in and maintain the cloud services, because those are still handled by the Microsofts and Amazons of the world. And what the pandemic's done is forced a hard shift away from on-premise to cloud, because people weren't going into the company site anymore, not only not to maintain equipment, but they weren't going to the company site to work. They were largely working from home. And of course, currently we've got something called the Great Resignation going on, where people that are being asked to go back into work are saying, hey, we're not going to do it, we're quitting. That's at least that's happening here in the United States. And so the end result is a huge focus on the cloud, and this idea of virtualizing the desktop. And so the latest initiative is to have virtual desktops that are located in the cloud. And now you can have any kind of hardware that you want at the endpoint, be that a smartphone, a tablet, could be a PC as well, which seems to be the most popular tool because it's one we're most familiar with. But it gives you a lot of flexibility. And once again, you're back to this idea of a centralized computing resource, very mainframe-like, but with the kind of control and capabilities you had with distributed computing. I'm not convinced the pendulum is going to stay stuck here. But the pandemic is clearly driving us to a much more cloud-centric world, and a world where you've got large cloud providers, mostly in the U.S. and China, that are providing these services on a global basis. And now, of course, as we move forward, the concern is, okay, if the data resides in a particular geography, does it have to remain in the geography? And currently laws do suggest that that's what has to happen, that customer data has to remain in the geography in which it is created, which is forced a wide distribution of these cloud services, which is kind of where we are now. We have centralized providers in the US and China, but we have distributed services that are located worldwide, allowing people to have the service in the country that they need it to be in, so they're not violating rules and regulations. And now we can even have healthcare organizations with cloud services where we couldn't before, and still be in compliance with those various laws that control the data that corresponds to patients and individuals. So it's an interesting environment, and a lot of the AI work going on right now is focused on the cloud, as is a lot of the quantum work in terms of quantum development. One of the leading quantum development platforms is the IBM Cloud, which is provided worldwide and has something like 40,000 different companies working in and around the area. And it is a way to provide technology into a region that can't afford the technology but still needs access in order to become familiar with it and not fall behind the technology curve. So that's kind of where we are now.
Mhm. Thank you, Professor Rob, for your excellent analysis. Professor David Smith. Yes.
Love Rob's introduction to it. I began in the mainframe days too, and the concepts of a mainframe is still around. And if you look at the early clouds, as Rob said, they really were just mainframes retitled and looked at different ways to do their sharing. Uh, but what is very interesting to me is, as Rob outlined very well, the different models and different modes of cloud computing. There's a dozen core computing concepts as you begin to talk with infrastructure, platform as a service, software, desktop as a service. Some of the newer approaches I'm seeing in the core services is you are having AI as a service. Uh, a lot of press on AI as a service lately. You're having IoT as a service. You're now having cloud computing security as a service, and many others. So the as a service in the cloud domain is going to really continue to grow quite a bit, and as you get there. Uh, Wednesday night, I was talking to a group of technology leaders, and we got really into where is the cloud and how is it changing. And the analogies that Rob used earlier are the type of things where I see us going with the cloud today as the Internet of Things becomes cloud centric, as autonomous vehicles are going to be cloud centric. Your autonomous machines, computer guided robots being used in everything from agricultural usage to home usage and others, they're going to be a cloud centric activity as well. So, just like in the early days of mainframes, you saw the big IBMs and the Unisys and the other big mainframes begin to be supplemented with companies like Digital Equipment Corporation with their machines, all the different mid-range mini computers that were out there, that then they were really more the driving factor to the PCs than the pure mainframes themselves. So that mainframe, middle range computing, in computing with the PC things, is actually how we're beginning to see the cloud transition more today. And one of the big terms you're going to see is edge of cloud computing. And and actually what has enabled the cloud to move out to the edge of cloud for computing, which is really an intermediary computing spot and storage spot between the Internet of Things and the things on the edge of the cloud to the core of the cloud, is the whole need to reduce latency, the whole need to be real time. One of the things I used to say is, and you look at core cloud computing, our mainframe computing, none of it was real time. It was near real time. But what you saw is when I collected something in the field, I sent it from my computing environment in the field over to the mainframe, had to input it there, had to process it, had to then take it to one or two other tools to maybe model it, process, package it, and then send it out. That's pretty fast, but it's not real time. And what we're seeing now is the cloud is transitioning out to the edge of cloud type of processing. We're going to see it get increasingly to where it can handle real time requests. And if I'm in an autonomous vehicle that's doing part of the analysis through the cloud, I want that to be as real time as it can so that I don't hit the dog in the street or things like that. If I have a medical Internet of Things, I would like that to be real time if I'm having a health emergency. So you're seeing the cloud go increasingly to the edge of cloud type processing too, but still keeping the advantages of the cloud, the centralized cloud environments itself. Uh, Another point on clouds today is where the cloud architecture is headed, it's letting us address local concerns of data storage and things, which were always a problem when we were in more of a pure single uh, centralized cloud. So the big clouds, the AWS, the Googles, the IBMs, the Microsofts, and others, they are now set up where their cloud is fairly invisible to people coming in. But when you configure it, if I want my data that I collect in UAE capped in UAE, I can do that in most of the clouds today. If I want it capped in Malaysia, I can do that with most of the clouds today as they begin to segment how the clouds are done. So that's an important thing of the cloud today than it is from when AWS first introduced their cloud. Last thing is what has enabled this and what has enabled the edge of cloud. One of the leading things that has done that is a technology called microservices. And microservices and containerization are the two things that when you combine them, it lets you make your application, what you're trying to do, not only transportable, but you can begin to use particularly microservices in something called a federated data set, a federated application. And that is where you can actually push them out to the regional parts of the cloud and from the regional parts of the cloud to the edge of cloud, and yet still have them working in federation with each other. That same type of federation is what allows the clouds now to also federate the back end, where I can have multiple types of databases. I can have SQL databases, NoSQL databases, I have geospatial databases. I can have time series databases. I have craft databases. I can have unstructured text type of databases there that all my applications can begin to use and direct the data to the appropriate type of database that is optimized for how I want to use the data. And that type of federation through this type of cloud environment also improves security because I can encrypt each of those differently. I can federate differently. I can take the federation from a centralized one, but still respect the differences in nation regulations because I can federate part of that in the United States. I could federate part of that in UAE or in Malaysia, like my example before. And that federation with the microservice and containers is really what's going to take cloud computing continue to grow it, continue to push it. And it's going to be an exciting time as we see this evolution, because as Rob said, the other big thing was there is hybrid clouds, and we deployed products in hybrid clouds and still do. But the challenge with hybrid clouds is responsiveness, and the latency goes up. It's very hard to deduplicate data on some of the hybrid clouds, even though there's tools to do that. And the other thing is if I'm in a hybrid environment and I am trying to push to real time, particularly using edge of cloud computing, it becomes a different problem of what is current and what is old in some of the hybrid implementations. And so those are just some of the issues, but some of the very good things that are happening about it too. And again, with particularly clouds becoming both global, but respecting regional and going to edge of cloud, it's a great time to be an entrepreneur and using the cloud services today.
Excellent, excellent. Professor Rob, my question: what are the security aspects provided with cloud?
It depends on the vendor. Each of the vendors in the U.S., those are the ones I know the best, came at the market a little differently. Microsoft came at it from the top down. Amazon from the bottom up. Amazon provided services to the individual for the most part and for a long time, but the end result was they weren't quite as focused on things like security as Microsoft was, who came from the top down and had to get the enterprise buyer happy right off the bat. You might have noticed that Microsoft just passed Amazon and Apple as the most valuable company in the world, and I think to a large extent it's because their underlying strategy is integrated. They make platforms, tools, and Azure fits right into that platforms and tool strategy, while Amazon is bifurcated between their cloud business and their retail business. The retail business uses the cloud business, but also limits the cloud business because it makes it very hard for AWS to sell to competitors like Walmart, for instance. Google I'm not real sure. Google saw the cloud as an opportunity, but Google has the attention span of a 4-year-old in sugar. And so they don't really spend a lot of time on any of the properties. It's a adequate offering, but they just don't spend the time and effort on it that Amazon and Microsoft do. So they're kind of a mess. And people don't trust them because Google's market is their primary revenue is selling data to your data to other parties, which means if you have a breach on the Google Cloud, it's less of a why did that happen and a more what did you expect. So that's an issue. They've got a fairly significant image issue going into this, though it is a competent product. IBM differentiates rather interestingly, though. They sell on multi-cloud, so the idea that they'll help you manage multiple cloud resources and maintain redundancy, because that's kind of a big thing right now, multi-cloud, because it means that if Amazon or Microsoft go down, you don't go down because you've got redundancy on the other player. And there's a certain argument to making that happen if you're a company of scale and you need to be up 100% of the time. So what IBM sells is the idea of managing multiple cloud clients and then overlaying it with the IBM cloud, which addresses your security question. The IBM decided to differentiate on security. And so the IBM cloud is secure first. So it's not as easy to use as an Amazon, as an Azure, because you've got different security hoops to jump through, but it is arguably more secure than either of them and sets as a superset above the other providers. So if you have a workload that needs that extra security, say it's your government account and this is intelligence, or your government account and this has to do with some other project that you need to be secure, then the IBM cloud dovetails right into that, and it carries both the appearance and the security capability that you need to justify the expense. Overall, with regard to cloud security, you are dependent upon the security implementation that the cloud provider has put in place. It's their equipment that you're using, and if for whatever reason that equipment is compromised, you will probably be compromised as well. However, all major cloud providers do provide secure containers. Those containers are arguably about as secure as you're going to provide even on your on-premise, and they typically implement a level of security around their hardware that an average company couldn't afford. They're providing it as a service. Their data centers tend to be isolated and secured as opposed to on-premise. I mean, I used to do security audits when I worked at IBM, and you just get weird stuff like people crawling over walls and stealing equipment. You don't get that kind of thing in your big cloud data centers, because those data centers are isolated. They are focused on the services they provide, unlike an on-premise environment where you may have your IT services in the same premises as your operations, and often in the same building. That typically doesn't occur with cloud providers. They tend to isolate their data centers, that low staffing inside, so the opportunity for a security breach is remote. On the other hand, these big data repositories are huge targets. I mean, it's like you have this where this huge gold mine is, and yes, you've secured it, but everybody knows where it is, and so they're going to come at it every once in a while. And we clearly had issues early on with denial of service attacks on these services that were successful. Not so much anymore, though. So they're about as secure as most people need, and if they need more security, you've got the IBM solution that lies above it, that couples with this multi-cloud example. And the other interesting thing about the IBM approach with multi-cloud is because they're not playing in the same space that Azure and AWS and Google Cloud are, they can more easily work between them. And historically, IBM is the only company that has successfully worked across competitors to supply solutions. They did that with their storage division, which is where I worked at IBM for a while. And we actually supplied most of the components for everybody else's storage hardware, but nobody knew it because we kept it quiet, and that allowed IBM to have a level of scale in storage that nobody else could touch. And it worked because everybody seemed to trust IBM until they didn't. But trust IBM with the solution, and then the end result is we got a really interesting ecosystem that was unusual, because you had a competitor supplying solutions for their competitors and doing so successfully by maintaining trust. And at the end of the day, that's probably IBM's strength is this idea of trust, which again goes back to security. If you trust the company to be secure and they are secure, you're comfortable. It doesn't matter if they are secure if you don't trust them, and it doesn't matter if you trust them and they aren't secure. You need both elements in place. Now, one other thing before we move on from this with regard to security, I did, when I was at IBM, partake in one of the largest security trials that had ever occurred during that time. And what we learned during that trial, we created a site that was very secure, and then we hired a spook, an ex-CIA guy that had skills to break into the site, and he did it within 24 hours, and he did it by not touching any of our security. What he did is he breached another company that was trusted, and they came in through their trusted links, and that showcased how you breach security in an environment like this. You don't try to breach security directly. You try to go in through somebody else that hasn't secured their site very well, and that's probably the big exposure to these cloud facilities, is the fact that one of their clients can be breached, and through that breach might be able to penetrate the rest of the site. That's probably what keeps them up at night. Now, they've deployed secure containers. These operations are segmented, they're secured, often encrypted, but you still have that issue that you've got thousands of people accessing the site legitimately day after day, and identifying somebody that's coming in with hostile intent becomes very difficult. And that's why their security needs to be so robust, but also why they carry a far higher security risk than probably any other business on the planet right now, because they are so attractive as an attack site, and because they've got so many people hitting the site who they don't know intimately and can't confirm deeply because they're employees of other companies. So it creates an interesting environment. And we'll see as we go forward whether it maintains. These things tend to ping pong back and forth. And the one aspect of the cloud that I didn't mention, which is endpoint, not only endpoint security, but endpoint computation, where we're now again taking a certain amount of the computational power. We're putting it either in remote data centers closer to the user, or we're actually putting it in the endpoint to reduce the amount of data that we're having to send back to these cloud facilities. Because as we move everything to these big cloud data centers, we've discovered that the data bottlenecks in the connection to those data centers, which is force these data centers to again distribute to lower the load on the centralized facilities, and then get more intelligent endpoints. So a certain amount of the analysis is happening at the edge, and then what's being sent to the cloud is just a subset of the data that's being captured, so that you're not saturating the network and bottlenecking as you go into the cloud facilities. So that's where the drama is right now, between things that are being analyzed at the endpoint and then collected and analyzed again in the cloud. And that creates an exposure, because now you're not sending all the data to the cloud, and that gives you an opportunity to introduce bias, because if that endpoint is leaving out certain kinds of data that you need to do the analysis is going to be flawed, and the end result won't be trusted. I'll give you one more example. I was working with a forensics firm, and a forensics data firm is a firm that you call to come in to solve a problem you haven't been able to figure out. And this was with Amazon. And what Amazon had is they were getting a lot of delivery failures, and the only way they were seeing these delivery failures were complaints from the customers that were supposed to get the deliveries. Instead of things happening overnight or in 2 days or 4 days, deliveries were coming in weeks, if not months later. And Amazon is heavily metriced, and their internal analysis didn't show up any problems. In fact, it didn't even show up that these things were showing up late. The only item they had that showed that these things were showing up late were the complaints from the users. And so the forensics firm came in and took a look, and they discovered what had happened is that Amazon wasn't capturing the relevant data. The Amazon tool said that the distribution points, their big distribution centers, were never to deliver to end users. And as such, they didn't capture delivery information from those centralized points. But a manager at one of the distribution centers had decided to distribute just from that center, and it was those deliveries that were showing up late. And because Amazon wasn't capturing the data, their analytics weren't recording the problem, and that's why it required a forensics firm to come in and discover it. It's, by the way, it's the same kind of job you do trying to catch a crime, but in this particular case, you're trying to capture an elusive problem, so you don't have the undertow of having people pissed off at you, and you come in as an analyst or a forensics analyst, and you're solving problems. It's a great job. If anybody is ever thinking about going into something into technology, forensic analysis is a lot of fun. But it does showcase the danger of data capture. If you're not sending all the data back to the centralized site, you can make bad decisions because of the data that you're not getting and you don't know about. The old saying is, you don't know as you don't know. That's really dangerous here. And so we have to be very careful as we introduce this idea of hybrid and this endpoint analysis to make sure that we're not corrupting the very thing we're trying to record and capture.
Excellent, Professor Rob.
Sure.
Professor David Smith, there is one of the question, explain what is the use of eucalyptus in cloud computing, and another things, what is the requirement of virtualization platform in implementing cloud? This is actually from our audience. Yes.
Great question on that one. And let me, though, first start by telling Rob, thank you for those IBM hard drives. And when you sold them to Hitachi, they really did go downhill. The virtualized environment actually works really well with cloud and can work within that. I can give you an example. We've virtualized our applications and things in using something called security and layers. And virtualization is one of the key elements in security and layers. And clouds, particularly multi-cloud, as Rob started talking about at the start of this last session, is one of the keys to also begin to do virtualization inside multiple clouds at one time. And it really does enhance security, and it lowers your risk and helps you deal with local conditions very well. Now, what it does to the development environment is makes it slightly more complex, and it forces you more really into extremely well integrated development environments that will let you begin to move things between clouds. And in particularly the differences, IBM, as Rob talked about, was one of the more secure clouds. In fact, IBM was the first cloud provider to build cloud centers in bunkers that were protected from EMI and had Faraday shields all around them and everything else to protect the data in the event of catastrophic activity. And AWS and Microsoft now both have high security clouds, but they are usually built for specialized customers. Um, and are very different. One of the things to your person with the question, though, Sharif, is that as they are looking at the virtualization, how to use that across clouds, they need to spend more time selecting the cloud providers that make the most sense with how their virtualization is going to work. Because as you virtualize more, some of the common tools become harder to use. Uh, the virtualization is a very good concept, but as you look at, particularly when I want to take a cloud provider and begin to segment more on a data basis, it complicates the data side of there a little bit because the way you use the tools become the shared tools, the shared resources, how you use Atomic, how you use some of the other services becomes a little bit harder to use. But there's the debate on the other side, though, is if I am going to be a multiple cloud provider, how much of the cloud's proprietary tools should I use? Because all these cloud providers have proprietary tools that they want you to use for their different types of machine learning, for their different types of natural language processing, for their different tools to do deep data analysis. But as you begin to build more and more upon those tools, they become less transportable into other environments, into other clouds and things. So to your person asking the question, it's just you need to do more due diligence as you're looking at the clouds, as you're looking at doing a multi-cloud provider environment, as you're doing a multi-region cloud deployment. All those are factors that really have to be taken into account.
Yes. Professor Rob, there is few other questions actually. Hello.
Yeah,
Yes.
sorry.
As we will share our content to the academy, that's why I'm asking some basic questions. What are the securities law which are implemented to secure data in a cloud? And second question, explain the difference between cloud and traditional data centers.
So the first question was what now? Ask that again.
What are the security laws which are implemented to secure data in a cloud?
The security laws depend on the country that you're in. They typically have to. For the United States, you've got HIPAA. The European Union has a law that I'm blanking on the name of the law that requires data remain in the European Union. Sorry, it's early for me. I'm just not remembering the name of the law. But typically, the country implements laws that define how data can move within the country and who owns that data and how it should be controlled. So each region has a law structure that you have to comply with. China's fairly robust in terms of requiring data to stay in country. EU is robust with regard to staying in country. Canada and the US each have their own laws and structure with regard to data management and movement. So it really does depend on the country. And if you're operating on an international scale, you have to become conversant with the laws as they exist in the country in which you're operating. Otherwise, you can get in trouble, and the fines can be rather significant. The European Commission has levied, multi-million-dollar fines in the past, and so even a large provider like an Amazon or a Microsoft or a Google can be brought to heel and forced to comply. the difference between a cloud and a data center is to a large extent the difference between buying a product and buying a service. With the cloud, you're buying a service. You don't own the hardware. You don't have to capitalize it. You don't have to depreciate it. You don't have to physically secure it. That's all owned by the cloud provider. You are basically outsourcing that part of your business to the provider, and you're paying for it based on the amount of their resource that they are using, and their different pricing scheme is depending on what it is you're using and how much of it you're using, and it goes down to the type of processor you're selecting, the amount of storage you've dedicated to the effort, and the and even the GPU and nature of the GPU that you're using, depending on the workload. So, but it's really the difference between a service and buying a product. It's OpEx versus CapEx. The earlier questioner asked about Eucalyptus, which is a project I haven't heard about in a long while, which is a framework for managing a cloud workload between on-premise and the cloud. It was bought by Hewlett-Packard in 2014. It is marketed underneath their envelope and works on AWS. So it's an interesting architecture, but it is somewhat limited by both the cloud providers that support it and the vendors that handle it. But that's Eucalyptus. Did I handle was that all the questions?
Yes, exactly.
Sure.
Okay, thank you. Professor David, what is the uses of API in cloud services, and what are the different centers deployed for cloud computing?
Many of the cloud providers have platforms built in as part of their clouds. So an API-centered architecture is the way to do it today. The ability to use APIs, particularly in a secure environment, is one that the developers and users need to spend time understanding the nuances of it. Rob began to look through some of the certifications, and you have, like the HIPAA, but you have also PCI certification, which is the financial industry certification you need to be very aware of if you're doing that. You have NIST, Common Security Framework certifications. If you're moving healthcare data, there's something called high trust. And only a few of the cloud environments meet high trust. And if you want to certify on high trust, you've got to make sure you work with cloud providers that can certify high trust. If you look at in EU and others, you have GDPR, but there's new enhancements to GDPR coming out that spend a lot more time addressing privacy. The China, the PRC requirement that Rob talked about, they are extremely strict, but they're not only strict about the data where it's stored, where the processing is done, but one of the problems with with China is that the Chinese government does want to have administrative access to your applications that run inside China and inside a Chinese cloud. So that is something you don't see really in the rest of the world. And if you're beginning to do business within China, you need to be aware of that. And you're probably going to do something in China that's called an air-gap network, an air-gap cloud, where it is separated physically from the rest of your applications in a global enterprise. So those are some of the characteristics going there. The other thing really is you look at this is that you have multiple currencies that you typically have to develop across these clouds. And some of the clouds tools on dealing with currency are better than others. And depending on the type of application you're running in the cloud and how often your prices change and how sensitive your margins are, you might want to look at a place where the currency arbitrage is done in real time versus places where the currency arbitrage is updated in set times of the day and night. and that needs to work across them there. Last thing on this portion, as you look at developers developing cloud environments, uh, some of the best practices in that area are people who understand the nuances of the core services of each of the cloud. Because even though they're similar, there's some important nuances between the core services. And part of it is the classic decision buy versus build. But with the cloud, it becomes even more complicated. It's, do I buy the services? Which services? Is that same service comparable across other vendors' clouds? Or versus, do I build it, and do I build it on one cloud? Do I build it for multiple cloud services and things too? So that buy versus build decision on the cloud side is a little bit more complicated. It's always a classic discussion because buy versus build usually translates to speed to market. And if I can buy it, if I can use the common services and things, I'm probably going to be faster to market. But then I own less of my own IP and I become less transportable. So again, the cloud, in particular, as we go to edge of cloud computing, those are going to become more complicated decisions processes that it's going to take more time and complexity to understand and get the answers there.
Thank you. Thank you, Professor David. Professor Rob, there are more questions.
Of course there are.
Yeah. Can you hear me?
I can hear you fine.
Okay. What are the business benefits involved in cloud architecture?
Well, the big business benefit is a shift to operating expenses and the lack of capital exposure that you get by going to a service. Somebody else owns that hardware, and often the problem for on-premise is coming up with the capital to actually buy the hardware, and then assuring that once you're done with the implementation, that hardware is now not obsolete. And that can happen. Often the evaluation period for new hardware can extend to years, and by the time you're done, what you've evaluated and tested is no longer current. And so you're paying a premium for out-of-date technology. With the cloud, you really don't worry about any of that. You are using somebody else's services. They're responsible for keeping it up to date. You don't maintain a lot of that capital risk, and you are able, because it's all services, all OpEx. You're able to better attribute the cost to the people that are using those services, which is kind of handy. We drive costs down to a departmental level now in many organizations, and the end result is you need something that can be driven down that far. And if you're talking about capital hardware, a department that might only need to use the system for a few months a year is going to feel a little uncomfortable paying for 10% of capital expense that will then be amortized over a 15-year period of time, or even a 5-year period of time, given the fact they're not sure they're going to be using it 5 years from now. So with OpEx, you gain flexibility in terms of how you can choose the hardware path that you're on. You lose a lot of the responsibility and difficulty with regard to overhead, and you're better able to attribute the costs of that use to the individual division that's using it. On the other hand, you are paying for overhead, and the larger you are, the more capable you are of buying at the same discount level a cloud provider can buy it. And so if you're relatively, let's say you're a government, and you're relatively stable, you're not really worried about big swings in terms of labor or support or market. To me, a government's probably the wrong kind of customer for a cloud resource, because they are so stable, they can justify the capital expense to buy the hardware. And you do gain a certain amount of control over the underlying data. And certainly, as we've seen here in the US and other countries, foreign hostile actors want to get access to that data, and often you can be better at securing it as a government, though Snowden might argue that maybe not. But can better securing that information and that hardware than a service. I mean, let's say if you were a country and it was your data and now you're at war, suddenly the provider is from the company that you're going to war with or aligned with the country you're going to war with. Well, suddenly they've got access to your data and maybe you don't. So governments, by and large, are probably at least centralized governments, federal governments, by and large, are probably less likely to find cloud services ultimately comfortable, even though there are governments rolling to it pretty hard, than say a vendor, a company that's in the consumer space, where you can get wide spins with regard to staffing, revenues, or whatever, and you need that flexibility a service provides in order to shift costs along with revenues to make sure you don't get underwater with regard to your capital expenses. So the benefits really are that flexibility, that OpEx, this idea that you don't really have to worry about a lot of the stuff. You don't have to be in the computer business when you're using a cloud resource, where if you're using on-premise, to a certain extent, the ownership of that hardware, maintaining that hardware, understanding where the vendor's going in the future over a 5-year or 10-year horizon, depending on how long you're going to amortize that hardware, is all very important. With the cloud, not so much. With the cloud, you're concerned about how secure is the service, how likely to change are they, is the ownership structure stable? I mean, we haven't had a case where a major cloud provider has gone under, but that is something you would worry about with a cloud provider that you wouldn't worry about with on-prem, because you've got the hardware on-prem. On the other hand, with on-prem hardware, we've certainly had situations where people get excited about some new server vendor or new storage vendor, and that storage vendor, server vendor gets acquired, and the company they're acquired by is not in line with what the company wants to do, or they go under, in which case you get no support for the hardware that you've acquired. And so the cloud provider in those cases can provide a certain amount less risk because of their scale and because you're not buying anything. And as long as you maintain flexibility, which is important when you're buying into the cloud, you do not want a hard tie to the cloud's resources. For instance, we mentioned eucalyptus before. That's pretty hard tied to AWS. If you want to go to Azure, eucalyptus is probably not going to do you any good. And with a cloud provider, you want to maintain flexibility. Ideally, at scale, you want to have multiple cloud providers, so you've got redundancy, and that keeps the cloud provider honest with regard to pricing. You can competitively price the services and shift where you want them to go. And if one cloud provider is having issues with regard to security or uptime or whatever, you can shift your loads to the other cloud provider and conceal and disconnect yourself from those problems. So make sure, as it would be with on-premise hardware, it is with cloud providers, that you have to maintain agility. You have to maintain your ability to move between the vendors so that you're not tied down to any one vendor or their problems. Flexibility as we go forward, because we've got the world order is clearly fluid at the moment. You want to maintain your ability to move between cloud providers if the political system changes, if the vendors' ownership structure changes, if their success changes. Be aware that of the providers, the major providers in the U.S., both Google and Amazon are currently under an antitrust cloud. IBM and Microsoft are not. So the antitrust cloud may force those providers to break out these services, which could cause some unplanned problems for anybody using those services. I'm not saying that you should avoid those services. What I am saying is maintain your mobility, so if that becomes a problem, you can shift to another provider relatively easily and your business doesn't suffer.
Thank you. Professor David, we are discussing about this business benefit of cloud computing. So if you share a few of your views.
There you go. Give me a moment to unmute there. The challenge with clouds, as Rob was saying, is there's a lot of regulatory movements right now in cloud because it's become beyond business critical. Even Department of Defenses globally, intelligence operations globally, big financial institutions globally are moving more and more to the cloud. So it's becoming business critical but also it's becoming more of interest to regulators, uh, and becoming more of interest to hackers, and particularly nation state scale hackers to begin to um, deal with it. Um, the other thing is Rob talked about is, and I talked about earlier too, is most of the cloud providers have multiple types of clouds and multiple approaches to them. You look at IBM. IBM has explicit clouds for Department of Defenses. IBM has explicit clouds for different government operations. They have public clouds. They have private clouds set up for large companies. Uh, and AWS is the same type of way. So a cloud is not necessarily a cloud when you look at it that way, because each cloud, even in one providers, can be multiple types of clouds, multiple areas of clouds. And again, depending on what the needs are, uh, some of those choices are is, do I work in their public cloud? Do I work in some of these private clouds? Do I work in some of these specialized clouds? Um, do I use one cloud provider in a very secure environment, but then do I push my applications on another cloud provider for the application interface, but federate the data back to the more secure cloud provider? So a lot of choices there. It's a great time to learn how to be a cloud architect, and a cloud architect and a data architect and an application architect are three different views of the matrix of how do I build today in this cloud environment? How do I begin to do it? The other very interesting thing is that you've heard us talk about the digital twin concept in many of these shows. Clouds actually make us, as we begin to look at this digital twin, this digital corporation twin, even easier to do, because I can take in different views. To me, the cloud environment today kind of reminds me of the movie The Matrix. And as I look at my clouds, as I look at my applications, as I look at my core services, my optional services, the regulatory impact, the certifications impact, it's like turning that grid, that matrix and the matrix around. And each time I turn it, I get a different view of my clouds and of my cloud providers and what my requirements are and what I must meet. So it's something that if you're just getting started in the cloud, you want to make sure you surround yourself with mentors, you surround yourself with consultants who understand it, take advantage of that, particularly as you begin to look at providers who can begin to do things with what's called the fog edge. And that fog edge is it's an intermediary step between the core cloud and the edge of cloud application. But this fog area is where a lot of the federation that I've talked about, that Rob's talked about, happens. And yet it's another intermediary step that is necessary for when you begin to use the full capabilities of clouds. Again, so a view of helping you do cloud architecture, application architecture, network architecture, and all of these uh, combined together to do that.
Thank you. Thank you. This is an excellent discussion. I'm really impressed, and I'm sure our audience also enjoying today's sessions. I request all of our audience, especially the government officials, the corporate and NGO and the academy, those who observing our show, you can share our content as much as possible. And beside that, I just want to share the World Talent Economy Forum uh, with some of the countries in Africa. We are working with local governance, and we are planning for taking their class, especially on policy development, We will work on regional, social, market economy, and COVID-19. So from our speakers, especially Professor David Smith and Professor Rob, if you are interested to take the class, you can. Especially we will take class of high official government employees, bankers, and the corporate people. So it will be 3 hours of sessions, and beside that, the audience, those who are observing our show, if you need this kind of policy developments, I'm sure Professor David Smith, Professor Robs, those who are our board of advisors for World Talent Economy Forum, our scientific committee member, they will happy to help them. So we are also helping different African countries policy development. We already collaborate with Colat Lab, and they are also working with local governance in Rwanda, Prime Minister Office in Rwanda, South Africa. So hopefully, World Talent Economy Forum contribution will be meaningful contribution for developing nations. And beside that, the audience, those who are really interested to collaborate with World Talent Economy Forum for this kind of training, this kind of open dialogue and policy development, I'm sure our board of advisors are happy to do that. So thank you everyone. This is an excellent discussion, Professor David Smith and Professor Rob. Very fruitful and very important discussion for academy and for corporations. I directly want to go for the concluding remarks. First, I request Professor Rob, what will be your concluding remarks for today's session?
Well, the cloud is certainly the present in terms of where people are putting their workloads. What we want to watch is the next evolution of the cloud, which takes us into the metaverse. Facebook, of course, has changed their name to Meta. It's kind of a rolling joke over here because the effort seems to be mostly to mitigate some of their bad reputation, as opposed to actually developing the metaverse. But the underlying concept is valid, and the idea of being able to digitize the world around us and then create an environment that you could move through is kind of fascinating, and it's going to take us quite a while to get there. Initially, we're going to see it mostly for things like simulation and for projects that require some type of deep architectural review by people that are remote from the underlying effort. But the metaverse is where you watch here, and then that's going to force a level of integration between the cloud providers that we haven't seen before, because you're going to have to be able to move between the different elements of the metaverse, and that's what a lot of folks are working on now, is this level of interoperability as we build this virtual world that will encompass everything that's real and anything we can imagine. So it's a major change. It's very much like being in the 1990s and seeing Netscape pop up with Navigator and create the internet. The metaverse is kind of the next example of what the internet can be. It's an offshoot. It could replace, but it probably will supplement for the remainder of our lives. And it's the big thing in terms of what's happening in the cloud today. And thank you very much, Sharif.
Thank you. Professor David Smith.
Sometimes Rob and I almost feel like we have neural implants on some of our thoughts on these. Because as you look at it, the metaverse is going to be a very big driver of how clouds are going to change. And the metaverse concept is going to accelerate the edge of cloud architecture and build out in most of these clouds, because of the metaverse requirements of really getting into augmented reality and others. It's going to require the timeliness where your lag times are short, your response time of doing the data is short. That's going to push you very much to edge of cloud. The other thing that is real interesting is, we hear about the networks with 5G, and 5G is both wireless and well as a network protocol and other stuff. That's going to have an impact as where clouds go. And you're going to see 6th generation pop up very fast because of the increasing requirements wanting to go to a metaverse type of interface. But the other huge driver that's going to shape clouds today is the Internet of Things. And the trillions of Internet of Things devices that are going to be out there. So where mainframes in the past were typically humans connecting into the computing environment, the future of clouds, humans are going to be a minor, very minor part of the traffic and the connections and the interactions going on the cloud today, and even a smaller part on the cloud tomorrow. But one of the things that I think we're going to see very much on the cloud evolution is that they're going to continue to be containerized more. You're going to see microservices become extremely important. You're going to see virtual environments continue to be enhanced and be used there. And particularly ones as I look at the regulatory impact and the customization that you want to do. When I put several trillion devices on it as a edge of cloud computing interface, as I put autonomous operations, both land, air, sea, underwater, onto the clouds. I put enhanced factory automation. I put autonomous agriculture and advanced sensor integration there. Clouds have to change. Clouds have to become more distributed. Clouds have to become more responsive. And I can't do that with a pure centralized cloud anymore. So, yes, the architecture is going to change. It's going to become more, like I said, edge of cloud centric. You're going to see more of this fog in the middle of the cloud where it's self configuring, self routing, self servicing itself, because I cannot wait and go all the way back to the core of the cloud to do that with what I'm doing out at the edges of the cloud. And so that's part of the future evolution of clouds. It is a huge marketplace. Building tools that take advantage of it is there. We're already seeing early instances of quantum computing as a service in a cloud environment. We're about to see, from what I understand, some early releases of biological computing as a service in clouds. So it's also letting us get to these advanced computational formats that are just now emerging in the commercial marketplace to take advantage of. So the concept's great, but just kind of step back as Rob started. It's a lot like mainframes in the mainframe evolution of from mainframes to microcomputers to divisional computing to personal computing to devices interfacing to computing environments like sensors and machines and like that. That same evolution is happening in cloud today. So we do have analogies that we can go back and look at to understand what's happening today. But the big difference between today and that evolution I just described is speed. We're going 100 miles an hour today on that evolution, when back then it was going 10 miles an hour. And that's what governments and entrepreneurs, universities, companies need to understand is the rapid pace of this innovation, the rapid pace of this movement. And a final point here, with where we're going in the cloud today, where we're going with artificial intelligence, where we're going with our abilities to interface, your legacy applications, your legacy analytics are going to fail in this new environment. Within this new security environment, which cloud is doing a lot to address, your legacy applications and your legacy analysis will fail. So you need to, as a company, as a country, understand the plateau we're entering in is really one where you need to stay on top of it, look at those changes. You know, we thought when we had the turn of the century, a lot of software is going to fail. There was massive movements to update it so it wouldn't fail as we entered 2000. While this new environment with the cloud, we need some of those same type of efforts on our legacy applications because they will fail as we move into this new type of environment. Uh, so really great things about it, but also warnings that come with it.
Excellent, excellent. Today's session is really important for academy and corporations, and I'm sure our audience will learn more things from you and Professor Rob.
Well,
Yes.
and governments too. Governments are going to be impacted by it equally as large as the others.
Yes, excellent. So yeah, yes, Professor, we are actually developing more relation with government and corporation, not only Asia Pacific, even in Africa and other places of the world. So hopefully our collaborations and our work will be very, very helpful for this global community. Thank you, Professor David Smith, for
Thank you so
joining
much.
today's thing. Thank you. Bye bye and take care.
Bye, all.